So this is a demonstration of the KCAD for a PCB design, and I have actually given an assignment which is actually to realize the PCB design of this particular automatic water level controller. So this is a circuit, and it's based on a 555 timer IC. You have a couple of resistors here and there, you have really everything, transistors, etc. So uh, the part of the circuit we are going to realize in KCAD is uh, uh, it's not the complete circuit. See, you have to realize the timer associated with the and associated resistors along with this channel, two resistors here and one transistor here. So we have to exclude this relay and exclude this water tank part. So in the circuit, in the PCB circuit, we have to put a connector here, so a 3-pin connector here, and probably two connectors here and here in order to connect the relay, and two more connectors at the VCC and the ground to connect the power supply. Okay, so we are actually drawing this 555 IC with these resistors R2, R1, R2, R3, R4, then capacitors C1, R5, R6 and T1 transistors, and we'll put connectors at these points. Here 3-pin connector, here maybe we can connect a 2-pin connector here in order to connect this relay, and we have a single pin connector for VCC and a single pin connector for ground in order to connect the power 12 volt power from the supply. Okay. So this is the schematic. I'm not going to draw the exact circuit, just I will give a demonstration. So first of all, I will draw a demo circuit. So here we need not take the components from the PSpice library because this is not a SPICE simulation. So first component we need is the 555, and it is this IC NE 555. So it's in the timer library, not the PSpice. You have to remember that. So click OK. So we have the timer IC. Now we can connect a couple of one resistor and one capacitor. I am randomly just connecting this capacitor to some point and one resistor to some other points. Okay, so resistor capacitor there. Then I need since we are having some connectors, so connectors. So this actually, see, you have so many type of connectors. You see the right side, you have many different types of connectors. So for see, this is a 1-pin connector. So let's take a 3-pin connector, 3-pin male connector. Okay, for connecting this board with the water tank sensors. Okay, so let it be like this, and we need some more connectors actually in the real circuit, but here I just introduce a single pin connector. So single pin male connector, maybe okay, one more single pin male connector. Okay, so this is enough for the demonstration. So this is actually a wrong circuit, keep in mind. This is just for understanding. Sorry, I didn't, this is the connection point. So from here we have to draw the connection line. So this from this point to this, from this point maybe to this pin, from this point to this point to this, just a demonstration, not the actual circuit. I am connecting this here. Okay, so this I am connecting to this. Oh, no. So this is the connection point. And now I need to place the ground. Power sources G and D. So this is the ground which I am placing here. And here it's maybe a VCC. You can search for VCC. Placing it here. I'm connecting it. With the first connector, and this VCC pin is connected with the same point. Okay, now we have the ground pin connected with this ground connector, and our ground is connected to this. Keep in mind again that this is not the actual circuit we have to draw. You have to look into the assignment sheet and draw the exact circuit here. So this is just a demonstration. Okay, so this is over. Now I will annotate this so that I will get name for all these resistors and capacitors and different components. Annotate. We've got numbers C1, R1, etc. Connector 1, jack 1, jack 2, jack 3, IC1, U1. Okay, so that's it. Then DRC to check any missing connections or anything. Only warnings, no errors. Leave the warnings. Oh, we have unconnected pins. So in order to avoid those warnings, we can actually click this. So two warnings will be. This is not needed actually. Okay, two warnings, and other two warnings are about connecting VCC with ROM pin, something like. Okay, so the schematic is over. Now we have annotated, we did the design rule check. Then we have to, now this is, since we are trying to manufacture the PCB or design the PCB, we have to assign footprints, PCB footprints for each of the components in the design. That means, see, here we have a resistor actually. So how this resistor will look like in a realistic world, so that, or in the PCB how this resistor will look like, or in the PCB how much space we have to allot for this resistor. So all these things are done by assigning the footprints. So we have to click this. Okay, it will load the footprints library. Okay, so we have all those components from the schematic listed here. So we have capacitors J1, J2, three connectors, one resistor and one IC. Okay, so capacitor, take the capacitor and assign footprints for the capacitor. So from the right side, capacitors, these are different footprints of the capacitor. You can see the capacitor footprints by clicking on this. So it will look like this in the PCB. So you have to have an idea how the capacitor looks like. See, whether our capacitors are like this, so it's not, it's actually, those things are surface mount. These are actually through hole capacitors, means these are mounted on the PCB by drilling two holes at this. These are the holes. So these are axial capacitors, but the capacitors you see, the dielectric capacitors you see in the lab are actually disk capacitors of this. They are not axial, not this, they are radial actually. Okay, so this type of capacitors you see. So you can select the first. So these are actually the different dimensions. The dimensions are actually specified here. So let's take one capacitor which is radial, first one. So this is first one from the list of radial capacitors. Okay, so this will have plus and minus. Okay, so double click on this actually to assign the footprint. So the assigned footprints will come here. So I am going to double click on this. So the assigned footprint came here. So it will look like this. Now I have to assign. Okay, next I will do the resistor. For resistors, so these are surface mount resistors, they don't have any hole to fix these resistors in the board. So we actually have, yes, axial. See, these these type of resistors we actually use in the circuits, in the common circuits. So these are different dimensions of resistors. Let's choose one. So let it be this. These are vertical resistors. You can fix these resistors in a vertical manner. And this is the first type of horizontal. So let's choose this from this list of axial resistors. Let's choose the first horizontal type axial resistor. These are other horizontal types. So, yeah, okay, maybe we can choose this or this. So maybe let's choose this. Double clicking. So by double clicking, that name will come here. See. And now regarding the 555 IC, the package or the PCB layout is actually DIP. So it's package DIP, dual inline package they are called. Yeah. So these are package DIPs. See on the left side the ICs will look like, but 555 IC we know that it's a 8-pin IC, so it's DIP. These are DIP 28 pins. So let's choose DIP 8, the first one in the list of DIP 8s. Now, so this has one pin missing, so this is the correct DIP. Okay, so let's double click on this. So that have been assigned. Okay, now regarding these connectors, so we can actually choose proper connectors. So there is a library called connector. So these are called so the connectors we use here are pin headers, header like connectors, vertical connectors. So let's choose connector pin header. So okay, these are pin socket connectors, we don't need that. Pin header connectors we need. So scroll up. Okay, pin header connectors. So these are multiple pin header connectors. Let's choose a single pin header connector. So the number of pins are written here. These are 8 pins. Pin header, the first one we can choose under this list. Pin header, not this. So here maybe so. So this is okay. This is the right connector we need. Single pin connector is this, but this is horizontally aligned. We need vertical connector, so we'll choose this. Okay, you can even check the 3D view of this. So it will look like this, right? Zoom out. So yes. So these kind of connectors. Okay. So this is the connector we want. and this is also a single pin connector, so you'll choose the same thing. And this is actually a 3-pin connector. See, look at the 3. So where is it? So these are single pin connectors, so we need 3-pin. These are horizontal connectors, we need 3-pin vertical connector like this. Okay, oh, so 3-pin vertical connector. Double clicking on this will assign that connector. Okay, so now you see all these components in the schematic have been assigned with some uh, footprints, which we actually see in the PCB. Okay, so it's over. Now click OK, and now, so this is done. Now generate the netlist. So netlist is actually the readable file format in the PCB design. So the PCB designer is another tool, so that will read this netlist, so that it will get all those footprint information from that file. So click on generate netlist, to give some name, so automatically the same name will come, that was same name as that of my schematic. So click save. Okay, so you have created a netlist. Now this you don't need. Now we can generate a bill of materials with some name, timer. So this is actually a text file of the list of components we use in this generate and close. Okay, now the phase of design in the schematic editor is over. Now click on this will open the PCB design tool. So click on this. So PCB design tool is open, and now click on this. It will import that particular netlist we have created right now. So that netlist has come here, timer.net, in the same folder. So read netlist. So this have read the netlist. Close. See, the components are appearing as a bunch along with my pointer. So I will click somewhere on the board so that the components, see, look at this, all the components are bunched together. Okay, so next we need is actually define a boundary for the for our board. So these are different layers in the board. So first, say these two layers are the copper upper layer and lower layer of the board. There are so many other layers, I am not going to explain all those things. So first select this edge cuts. Now select this not this. Since we are in the edge cut, we can use this tool to draw the edges of the PCB. Stick on to these points. So I am drawing an approximate size of my, see, this is just a guesswork. You will assume that the dimension of our board will fit into this small area. Okay, so press escape so that line will disappear. Okay, now we have, now click on now this is the PCB boundary. So our PCB dimension will be this. This dimension is actually in mm, so you can see how much dimension, how much is the size of this. So now click on this and select one component and drag it to some comfortable position somewhere in the board. Then see, this is just this is just some kind of intuitive uh, methods. Just we'll distribute the components to different locations, so that is okay. Now we have a connector here. So connectors usually will be there at the boundary of the board so that we can easily connect external components to it. So now I am clicking on this. Oh, it's not edit, and it's actually moving that. So click on this component and move it to some other points, maybe Okay, I'm placing it here. Now this is a connector actually. Move it to the boundary of the PCB. Now this is another connector. So you have to zoom in and select the components. Otherwise, say if I click on this, only that pin is selected. So click on this component, and now this is the 3-pin connector. So let's place this component in the boundary, but this is not a comfortable way, so rotate it clockwise, and now I am placing it at the boundary. See, these are placing the components, distributing the components and in the proper way in different parts of the board is just just a skill of the PCB designer. It's not about electronics or anything. Okay, so I have placed, but I think I'm not that good in placing these components comfortably.